Hey everyone, hope everyone's doing well. I have a new video for you today, a new lesson on completely new topics. So we are going to move on from chapter 8 that we did before the break. I know chapter 8 was a little bit difficult, especially to learn online, and those skills, definitely a little bit challenging. So they definitely are important. I do want to emphasize that they are important. You're going to need those skills, a lot in the future in calculus and all that, and even a little bit in geometry. So hopefully you're able to practice them enough, but we will have to move on from them for now. And if we do have time, maybe we'll revisit them just to do some extra problems. But we are going to switch gears, and it's going to be completely different from what we've done all year because we're going to end the course with a little bit of trig and geometry to get some of you ready for geometry class, or just to highlight some topics that you'll need in the future. So hopefully you'll find it a little bit more interesting, and at the very least, different, just because it is different from a lot of the other algebra stuff. So let's get started. So we do have to start with a little bit. It might be a little bit of review for some of you, but if it's not, then definitely pay attention and soak this in, because these are some basic topics that you'll need to remember for a long, long time. So for those of you that do know this stuff, definitely treat this as a review, and hopefully it'll be a breeze for you. But otherwise, this is what we're starting with. This is right triangles. We're going to talk about triangles, a little bit about triangles in general too. As you know, triangles, they're figures. They have three sides. Right triangles are the same thing. They're just a specific type of triangle, and all that means, if you are a right triangle, is that you have a right angle inside, right? So each triangle has three sides and three angles inside of it. If you're a right triangle, you have one right angle, and you can only have one right angle if you're a triangle. And a right angle, as we know, as you see here, if you don't know this already, is an angle that measures 90 degrees. So it's like a square, right? Like an L, a straight edge. And when you see a drawing of a triangle, this symbol here that creates this little box, that means that is the right angle. So here we see that this bottom right corner, that's the right angle. And therefore, this is a right triangle. Now, what's special about this is that when we have a right triangle, as we see in the second drawing, we name the side specific things. And you've probably heard this word before, but the hypotenuse is the side here across from the right angle. So, and the other two sides are legs, and that's all that's said here. So and what the hypotenuse also happens to be the longest side. So it's the longest side of the right triangle, and it's always across from the right angle. So once you see this box thing, or this is 90 degrees, you just go all the way across, and then this side right here is the hypotenuse, and it's the longest, and that's that. And here's what I mean about things about triangles that we do want to keep in mind, is that the area of a triangle is 1/2 base times height. So something to write down and know. And then the angles of all the angles in a triangle, which there are three of them, right? They all add up to 180. So we go back here, right? This 90-degree angle in a right triangle, there's going to be 190, and then the other two have to add to 90 to make 180. So these other two will add up to 90 also, just because if one of the angles is 90, they all add up to 180. What do you have left? 90 degrees. So we'll review that a little bit more if that wasn't clear. But just know that all the angles of a triangle add up to 180 degrees. So three angles all will add up to 180. So now this is pretty much the crux of what we're going to talk about, and that's the Pythagorean Theorem. You've probably heard it before. Again, if not, no big deal. But the Pythagorean Theorem is specifically about right triangles, and it's apart from the quadratic equation, is the number one equation / formula that is going to be important to you for now. So definitely get as much practice as you can. Now, when we have a right triangle, the first thing you want to know is just the naming system of it. As you see here, here's the right angle with this square. Across from it is the hypotenuse, and the hypotenuse will always be C for the purpose of the theorem and the equation. Okay. The other two legs are A and B. It doesn't matter which one's A, which one's B, but the legs, which are shorter than this hypotenuse, are just A and B, okay? So the legs are A and B, the hypotenuse is labeled as C, okay? And here's the meat of it, right? The equation is A squared plus B squared is going to equal C squared. So if you add up the two legs after squaring them, that number is going to be the same length as just this hypotenuse squared. And that becomes super important. And so here's an example of when you'll have to find the lengths, one of the unknown lengths. In this triangle, we confirm that it is a right triangle because we've got this symbol here. So that means this is 90 degrees. And then we have two sides. One is 3, one is 4, right? And typically, just to keep in mind, a lot of these figures will not be drawn to scale. So just keep that in mind. I know it looks like this side is shorter or longer, but just try to get over that fact that these figures are not always going to be drawn to scale. So the hypotenuse, and you always, for those of you that haven't done this before, right, you always just want to get used to knowing which side is what. The hypotenuse right now is this question mark, right? And so that we're just going to leave as C, okay? The legs are 3 and 4, okay? Because they're not across from this right angle. They're next to it. So the legs are 3 and 4, so we have our A and B. So the only unknown right now is C, right? So we just fill in the equation. That means that 3 squared plus 4 squared is going to equal C squared. 9 plus 16, and this is mostly mental math, right? 9 plus 16 equals C squared. That means C squared equals 25. And then last thing you have to do, right? Take the square root, and then that means that C, as you see here, C equals 5. And obviously, when you take the square root, you can get -5, but we're dealing with lengths of a triangle, right? So with figures, it's all about lengths, and lengths can't be negative. You can't have a triangle with a hypotenuse that's -5 centimeters, right? That doesn't make sense. So the answer is +5. Just keep that in mind. So that's that. Not too bad, hopefully. Let's just do one more example for now, where the unknown is a little bit different. So here I have another triangle. We identify that it is a right triangle, right? So we have our symbol here. That means this is the right angle, and across from it is the hypotenuse, which I happen to have labeled here as 12. We have one unknown, and then another leg is 6. So as I just said, the hypotenuse is going to equal 12 because it's across from this right angle, and that's our C. The legs are 6 and are unknown, and that's our A and B. So we just fill in the equation. We got 6 squared plus B squared, because it's unknown, equals 12 squared. That means 36 plus B squared equals 144. We subtract 36 from both sides, right? That's what I did here in my work already. Because at this point, we're solving for B, right? So we're going to have to go about a different way. So we get B squared by itself. And then B squared equals 108. Again, we take the square root. And here we have B equals the square root of 108. And now this is where you want to brush up on your square root radical skills, right? Where it kind of just looks right off the bat that is not simplified as much as possible. You don't want to use your calculator, and I'll show you that at the bottom. I wrote that down. We don't want to use our calculator and get a decimal answer. That is not typically what we want to do, just in terms of this course. But with word problems, sometimes you'll have to get an exact measurement or an estimated measurement. For now, though, just make sure you have an exact answer, which means we're not going to put in square root 108 in our calculator and then round it to the nearest tenth or whatever, right? We're just going to simplify using our skills from back in chapter 1. So if I have the square root of 108, we just, you do some guessing and checking, and you figure out that 108 is 36 times 3, and that's helpful because 36 is a perfect square. So if we do square root of 36 times square root of 3, square root of 36 is going to simplify down to 6, and the square root of 3 stays. And so we turn square root of 108 into 6 square root of 3, which is a lot nicer looking than square root of 108. And so our final answer is actually here, where B is equal to 6 times square root of 3. And as I said, the the big thing is don't use your calculator to give a decimal answer. Your answer should be an exact form. Exact form meaning, leave the square root there, leave the radical there, and don't round the decimal. So that's that. I'll post a worksheet to do some practice on just examples like this. In the meantime, soak this in. Watch other videos. Like I've always said, watch other videos if you have to, and just study it for now and practice if you need to. And you'll see the homework worksheet soon enough. Thanks.